Okay, so these are some drill practice. By that I mean I've got 12 problems. I'm going to write them down, and then I'm going to give you 2 or 3 beats to write down your answer, and then I'll continue. And when we're finished, we'll just go through and run through the solutions. Okay, so let's see how we do. Number one, y equals pi. Write down the derivative. 2, f of x equals 2 to the x. Number 3, f of x equals 5x to the 4th power. Number 4, 4x to the 5th plus x. Number 5, y equals 4x to the 4th minus 5x minus 3. Number 6, y equals x to the 3/4 power. Number 7, y equals 5/4 x to the 2/3 power. Number 8, y equals minus 4x to the minus 5 power. Number 9, y equals 3 divided by x squared. Number 10, y equals x to the 5/3 power. Number 11, y equals minus 2 times the 4th root of x. And number 12, y equals 2/3 x to the 4th plus 5x minus x to the minus 1 plus e squared. Oops, ran out of space there. You see that? The last one is 2/3 x to the 4th plus 5x minus x to the minus 1 power plus e cubed squared. Okay, how'd you do? Let's go through and correct these. Y equals pi, y prime equals 0. Y equals 2 to the x. Y prime equals 2 to the x, natural log of 2. If we have 5x to the 4th, the answer will be 20x cubed, right? Because you bring down the 4, multiply by the 5, subtract 1. Now, when you have a sum, you take the derivative of the sum. So f prime of x is going to be 20x to the 4th power plus, now this is, you bring the 1 down, right? And then the 0 power, so that's just going to be a 1. Y prime is equal to 16x cubed in this case, minus 5, and then plus 0, right? Because the derivative of a constant is 0. Good. And then y prime is equal to 3/4 times x to the 3/4 minus 1. Okay, what's 3/4 minus 1? That's minus 1/4. Good. 5/4 x to the 2/3. We're getting into some fractions now. That's going to be 5/4 times 2/3 x to the 2/3 minus 1, right? And so that'll be, the 2's would cancel. So that'd be 5/6 x to the minus 1/3. Okay, and you should try to put your fractions in least or in factored form, right? So now I bring down the 5. That's going to be 20x to the minus 6 power, right? Now this one is a little bit tricky, right? I have to write this as 3 times x to a power before I can differentiate. So we write y equals 3x to the minus 2 before we differentiate. Then we differentiate to get minus 6x to the minus 3 power. Good. Y equals 5 x to the 5/3, so y prime would just be our 5/3. X to the 5/3 minus 3/3 gives me a 2/3 power, right? Good. And then for this one, we have y prime is, oh, I need to rewrite it first. What is the 4th root of x, writing that as a radical? That's going to be the same as minus 2 times x to the 1/4 power. And so just as a side note, right, if you have the pth root of x to the q, or the q, let's say the pth root of x, all raised to the q power. Oh, let me do that differently. Qth root, p power, q and p. Then you can rewrite that as x to the p over q. We normally write it p as q. That's why I had to reverse those. Okay, let's see here. Did I finish that one? Y prime now is equal to minus 2 times a quarter is minus 1/2. X to the quarter minus 1 is minus 3/4. And our last one, oops, I guess I shouldn't have gotten so far down the page. So I'm going to have 4 times 2/3, which is 8/3, times x cubed plus, now that's just going to be 5 times 1, right? Minus, the minuses actually cancel, so that'd be a plus, x to the minus 2. And the derivative of e squared is 2e, right? No, it's 0 because that's a constant. Did I catch ya? Okay. So let's try some more. Go ahead and pause the video here, and I will be back with some more problems to work on. Okay, are you ready? So this is a little bit different. We're going to have y is going to be a function of different variables. And so for the variables, when we differentiate, if we only have one variable there, or one unknown there, go ahead and assume that that's the variable that we're going to differentiate with respect to. So I thought we'd do the first one together. If y is equal to minus 3r to the 5th minus 5r squared, then dy over dr is the notation you might use. That tells you that we're differentiating y with respect to the variable r. And so now the r is the variable, so we're going to bring the 5 down and have minus 15 r to the 4th. And then we'll bring the 2 down, so that'll be minus 10 r to the 1 power. You can just leave it as r. Good. So are you ready? So now be sure and indicate what the variable is when you start your derivative. Okay, let's get started. Number 14, f of s is minus 3 over s squared minus 4 over s to the 4th. Okay. Number 15, f of x equals 2/3 x to the 3/2 minus 3/4 x to the 3/5 power. Okay. Number 16, h of s is equal to the square root of 2 times the cube root of s plus the square root of 2 times the cube root of s. Okay, you might notice that was the same expression. I actually meant to put a 5 there, but that's okay. How about the next one, number 17? If y is equal to 5c, we want to differentiate with respect to x. And the last one, and again, we want to differentiate with respect to x. Y equals a times x to the 3a power minus b times x to the 3c power. Okay, let's go through the solutions now. For number 14, we have f prime of s equals, so this was s to the minus 2 power, right? So when I bring minus 2 times minus 3, I'll have a 6, s to the minus 3, right? Minus 4 times a minus 4 will give me a plus 16, and then that'll be an s to the minus 5th power, right? Plus c. Good. F prime of x, in this case, will be, let's see, 3/2 times 2/3. That's actually equal to 1. So I'm just going to have x to the 3/2 minus 1 power. 3/2 minus 1 is equal to 1/2. So that's going to be, let's see, 3/2 times, or 3/4 times 3/5 will be 9/20, right? And x to the 3/5 minus 1, which is 5/5, will be minus 2/5. Good. Number 16, because this is the same, right? You could just say that this is 2 square root of 2 times s to the 1/3 power. And so then the derivative would be just 2/3 times the square root of 2, s to the minus 2/3 power. Good. Now down here, do you see an x? No, therefore this is treated as a constant in this problem. And so dy over dx, we would say, is equal to 0. Now, what if I had changed the problem, and what if I had said differentiate with respect to c? Right, then what would dy over dc be? So in this case, dy over dc would be 5, right? So it does depend on what the variable is that you're differentiating with respect to, right? And number 18, let's see. So dy over dx is the problem, right? And so just treat everything else as constant. So here we would have a 3a coming down times an a would give us a 3a squared x, and then 3a minus 1 in the exponent. Similarly, bring the 3c down. 3bc is all we have, right? 3bc. That's normally the way you would write it. Times x to the 3c minus 1 power. Excellent. Very good. So this is just a set of drill problems for 3.1. We may do a few more, or I may save them for the next section and then put a few of these in on top of that. All right. See you then.